All right, so as we continue moving forward here, all right, see, we'll move forward a little bit. I think we're over halfway done with the materials we want out of the book, and that segment that we've been watching was, we want to say, supplemented the material that we were referring to in this class. Uh, we'll easily finish chapter tomorrow, I think, and then review the next 2 days. And then this will also be included on that exam. And the reason we see it written like this is we have some information to add to it. And something along the lines of, just to give you somewhat of a clue, would be something like, one of the things, all of these probably branched from this common ancestor. And why is it? We verbally said it, but we just never wrote it down. Because it was the first vertebrate, okay? And being a vertebrate meant, of course, the skeleton was something that developed from the inside rather than that of the outside. Now, branching off of all of these, we pretty much put them in order. The first fish and a hynerpeton. What would that be? What was that? It was a fish that developed limbs, in other words. So the first what, maybe the amphibian that crawled on the land. Now, as far as reproduction is concerned, the amphibian or hynerpeton and the cephalaspis, which is a fish, their reproduction takes place where? Okay, now, and we'll elaborate on that. Don't think you got to be taking this in verbally, and if you don't remember what we said, that's something that has passed by. No, it's one of those aspects we will elaborate on these and try to make sense of them. So, as far as reproduction is concerned, how is this Petrolacosaurus different than the other two? Well, in order to answer that, you have to think about, what is a Petrolacosaurus? It was considered one of the first what? What comes after the amphibians? Which are what? Reptiles. So, what was significant about the reptiles as opposed to amphibians in regards to reproduction? Yeah, because their eggs had a shell on them. Also, you said a three-chambered heart and lung breathing. All of those are true, but reproduction's different between these two. But as far as movement, what do they have in common? Yeah, 4 legs. They're tetrapods. Okay, so again, we'll elaborate on that and make sense of that. So it's not something that it's, if you choose to miss it, well then that's your choice. And if we're working on other things, well then you may have missed the bus then. Okay, so as we continue with what we see here, this is approximately where we left off, I believe. That one or maybe this one. I remember talking about this in class, I believe. At least it was on the Science Channel. One of those aspects we said, you know, if it's something that you may want to go back and look at. So I believe this is where we begin. Then, does that make sense? Yes? Past this. This is where we... Okay. So one of the things that, if we want to make sense of this, okay, which one of these do you think is a short-term fix, in other words? If you adapt to something or if you acclimate yourself to something. Acclimate's going to be more so of a short term. And this is how we want to make sense of this. Let's say if it's, for instance, 45 degrees in February, even March, does that feel warm to yourself? Probably. I think you would agree. But when we get towards the 1st of July or the last part of June and it's 45 degrees, we probably really don't care for that because we're just not used to it. We haven't acclimated ourselves to it. Okay? So being I can't say that word, acclimated, and then this is the process, okay, is a short term. Adaptation is something that will take place over time, where maybe you are gaining longer legs, or your fur is getting longer, or maybe you're getting bigger teeth or more specialized teeth. So it was a large reptile that was before the Gorgonopsid that was very significant as far as, let's say, being a carnivore, because it had these special types of teeth, not canines. There was a dimetrodon that had what we call bicuspids, and we have those as well. And the reason for that is sometimes if you're not careful, if you are chewing away, and if your tongue gets, you will notice whether you hit your tongue with your bicuspid, because it'll probably almost shear right through it, or it's certainly going to cause some pain. And I would be willing to bet that that's happened to some of us at some point or another. Okay. Is there such a thing as a living fossil, do you think? We're talking about remains that died long ago. Those are fossils, but is there such a thing as a living fossil? You said yes, that is correct. So what do you think might be an example of a living fossil? You're thinking alligators, because we saw examples of those. Those were not labyrinthodons. I think it started with Tasmatosaurs. Yes, that's what those were. Okay, those you could, like alligators and crocodiles, like you said, could be examples of living fossils. What you would have seen millions of years ago resembles very similar to what you see now. Even scorpions, you could say, are examples of living fossils. The only difference that we would know when scorpions first appeared as opposed to modern day, what's the difference that we would see? Yeah, they're much smaller. Well, why would those animals have to have that adaptation when they move on to land? Yeah, true. So, can they move as fast when they're bigger? The answer is no. There's two things that every animal needs for their metabolic rates. One is lots of nutrients, and the other might be what, do you think? Well, not speed. Well, true, that'd be considered as food. Yeah, lots of oxygen then as well. So what happens is the available air did not match what it needed for its metabolic rate. So in order to do that, it had to downsize. Okay, so that's one of the things that we see in this case. Again, a living fossil. So look at this. It says fossils lead to the most powerful evidence of evolution. So if you had seen a skeleton of a chasmatosaur or an early alligator and seen a modern day alligator's skeleton, you might think they're very similar. So that fossil would have to be direct evidence of a very early version of that reptile. Okay. And then let's see here. We're getting close to the end here. And tomorrow we'll go in a little further in depth. Let's just get what we mean by gradualism and punctuated equilibrium down. That's probably after this one, I want to say. because typically we read that in class, is what I'm getting at. Okay. Does everyone have this information that wants? Yes? Okay. Then just go ahead and do this last one. Then I want to work what's on the board. And one way to picture this, oh, it's right there. I just went past it. I didn't catch it. One way to look at this, we're talking about gradualism. You could say we as individuals could look at gradualism because we slowly change over time. Our body form does not change because we just look like small, tiny humans when we're born, and we just get bigger. That is a gradual change. Unlike punctuated equilibrium, where you may see something very small like a tapir, which doesn't mean anything to you now, but then I believe is a close relative of a horse. So where do you get a horse from a tapir? It looks like a rat. Well, throughout the course of evolution, nature selected these animals to go through punctuated equilibrium. Short changes of what that animal looks like. That's punctuated equilibrium. Gradualism means this looks like the same animal slowly changing over time, as opposed to tiny little bursts of a change. When I said tapir, do you know what I'm referring to? When I said tapir, you knew what I was referring to? Okay. Yes. Should know someone that knows the equine family would know, because they don't horse around. Yeah. It's like I tell other classes, if you smile, see, if you smile and do it like a knee slapper, you're not going to break your face. Trust me, it's not going to break. See, you can even do this. I bet it sounds funny if you actually listen to it again. No? Or is it, or if is it maybe it gets to sound like Jim Carrey was in that, was it called Bruce Almighty? Was that the first one? Or is it Evanall? Which one's first? Bruce Almighty, I think. Anyway, is it Steve Carell that's in the show called The Office?
Yes.
So you have Jim Carrey's character working on the teleprompter, and Steve Carell's character is trying to read that. Has anyone ever seen the movie Bruce Almighty? And then what is it? And that's what it gets to sound like in class after a while. True? Because it looks like. See, for those of you who did smile, you didn't break your face, did you? No, of course not. That would be ludicrous. Yeah. All right, so that does it for today. We'll continue, but we want to start putting this information down so we're ready to go for Friday. Okay, so again, we're just done with this part. So what were some advantages then? Now again, this is something that I think if we ask these questions, you're going to remember. Okay, so that cephalaspis, what might stick out in your mind? What was true about that? What about the head? It had a bony head that was protecting what we consider Mother Nature's first what?
Brain.
First brain. Okay. So when we're referring to that of a cephalaspis, okay, it has what we call a cranium. Okay? So if you know anything, I try not to leave this for very long because this looks kind of disturbing to me when you leave this behind, doesn't it? For anyone who's wondering what we're talking about off screen, I just have a skeleton model and pulled that off, so it just leaves the rest of the body. So when we're looking at this, okay, this whole structure would be known as the what? Skull. Yeah. This whole thing is the skull. Okay? But on the other hand, what we see up here, there's 8 individual bones that make up something more specific on the cranium. That's right. So what we see here, this cranium has a protective function. And we already alluded to that. The first cranium was protecting a brain. Okay. All right. So what was the great adaptation that this cephalaspis had as far as reproduction goes? Why did it go back to the same pool where it was born? Because it, well, sort of. How did it know how to get there? Well, what about his brain? Something. Yeah, it had what we call memory. Okay. And then finally, what type of reproduction are we talking about with the cephalaspis? True. But where is it taking place? In the water. So that is aquatic reproduction. Okay. Which you could say may or may not be an advantage, but at that time, that's what nature selected these animals to do in reproduction. Okay. So when the narrator was talking about how they remembered where to go, how did the scorpions end up there? Would they have known to go to this pool because we got these fish coming through, so it's an easy meal? The answer is no. Why were the scorpions there? Just dumb luck. Okay? So sometimes when it comes to survival, it's not just the strongest. Okay? Sometimes luck has something to do with it. Might not be the fastest. Then also can be this up here. Some of the smartest animals. Okay? So, again, maybe to help us out so we know what this is a fish. Okay? The first fish, the cephalaspis, that had this cranium that protected a brain that also had memory, but then reproduced in the water. Okay, so what was the hynerpetin then? Okay, this would be an early amphibian, so we're just going to write amphibian. So even when we look at modern day amphibians, there's a couple things that we know is going to be the same for this animal that we're talking about on the board as opposed to what we would have here in present day. Okay? Reproduction. What about it? Okay? Aquatic reproduction. We're kind of like a peripherin. You know what a peripherin is? It's an animal with many pores in it, kind of like a sponge. So we kind of like a peripherin, or we're soaking all this information up. We are. Okay, well, 1, 2, wouldn't be the only one. And if some people can soak it all up and be just fine. Okay, so we said before, locomotion. How are these animals getting around? 4 limbs. But what's true? Are they splayed out? They're at 90-degree angles, but where's their belly in regards to that? Yeah, scraping across the ground, okay? So, like modern day amphibians, what's their skin like? Smooth or rough? Slimy, that's a good word. Who said slimy? Okay, so in that case, they actually have a moist, smooth outer skin. Now, if you want to say mucousy, slimy, yeah, that's certainly true. Now, why is it that these animals back then, like modern amphibians now, have to have moist skin? Why would that be? Do you think? If they dry out, they can't breathe. Okay? Their respiration is still tied to having moist skin because going way back to chapter 4 in here, yeah, I know, we still talk about that even in zoology. How does blood gases from the atmosphere into animals or from the bloodstream into cells? It starts with a D. Diffusion. That's right. Okay? So in this case, what we see happening is that oxygen then can diffuse through that outer skin that is really, really thin and slimy because we don't want it to dry out. That's right. What about respiration? Is it well, we said they need moist skin, but they also have what? Not gills, lungs. Okay, so these are lung-breathing animals as well. Okay, and how many limbs does it have? Don't count the tail. So what would that be an example of? A tripod or a what? What means 4? You know, that would make sense, but it's not a quadrupod. It's a tetrapod. That's right. Okay? So it's a lung-breathing tetrapod. And let's see here. Legs are at right angles. And because of that, we said, what's true about their belly? It's close to the ground. Okay, I think that's enough to go over for today. Unless you say, oh gosh, we need to go over more. So I'll ask you the same questions. We're going to soak this up like a sponge. This material. We're going to soak this up like a sponge. Okay. Ask and answer. All right. So keep in mind, we have an evaluation coming up here on Friday. You have papers that are due tomorrow. Don't forget about those. Okay? We'll catch up to you next time.